Okay, let me give you another example, okay? Look at number 7, okay? We are talking about the existence of uniqueness, existence and uniqueness of the second order linear differential equation, okay? Look at the equation. Definitely second order. Classification is very important, okay? And when you look at the coefficient function, those are all function of t, right? Which means it is linear, right? And we talked about the existence and uniqueness of like second order linear differential equation, okay? In theorem number 3, okay? So like, to apply like the theorem 3, and we should try to make it as the standard form, which means we're going to divide by t minus 1, which is leading coefficient function, okay? So let's start from there, okay? Divide by t minus 1 on both sides, okay? Then your differential equation can be written by y double prime minus 3t over t minus 1 y prime plus 4 over t minus 1 y is equal to sine t over t minus 1, okay? That's it, right? It is linear differential equation, okay? Then, okay, let me rewrite your p, q, and g term separately, okay? Because we have to find the interval for continuity, okay? Here we go. Your p is the coefficient y prime, which is negative 3t over t minus 1. And q is 4 over t minus 1. And right-hand side, which is g, is sine t over t minus 1, okay? Look at that. And first of all, like look at g function. You have sine t on your numerator, okay? But keep that in mind. Trig function is always, I'm sorry, not trig function, all the trig function, okay? But the sine and cosine functions are continuous everywhere. So you don't have to worry about that function, okay? Only the troublesome is your denominator, which is t minus 1, okay? So we know your all p, q, and g functions are not continuous at t equal to 1, right? That's it, okay? So here we go. All these functions are continuous on minus infinity to 1 and 1 to infinite, which means like your functions are not continuous at x equal 1 only, right? And then like at this moment to find the largest interval for the existence and uniqueness, and you have to check the initial condition, okay? Your initial condition is defined at -2, right? So the largest interval, give me 1 second. Containing the initial bad writing, which is equal to -2 is negative infinity to 1, okay? So also like that's it, like this is the largest interval, and by the theorem number 3, it is stated like in my lecture note, okay? Unique solution exists on minus infinity to 1, which is the largest interval, okay?